Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So in this session, we are going to start quadratic equation. Okay, this is a very amazing and very important chapter for Boot's point of view as well as for IIT-JEE point of view. Definitely, this is a very important chapter. Okay, JEE Mains, JEE Advanced, every year question is asked from this chapter, or the concept that we learn in this chapter are applied in other chapters also. Okay, so this is super important. Okay, there are so many conceptual things that we are going to be studying in today's session. Like in this session, we are going to be learning about polynomial. What is a polynomial? Okay, relation between roots and coefficient, we'll be learning about that. Factorization of polynomial, we'll be learning about that also. Okay, so in this session, these are the topics we are planning to target. Now, first of all, without any further delay, let's get started with what is a polynomial. A polynomial is an algebraic expression of the form. See, this is the form of a polynomial. This is how it looks like. Okay, see. This is how a polynomial looks like. Yes. Px is equal to a0 plus a1x plus a2x square and so on up to an x raised to the power n. The highest power of x is known as the degree of this polynomial. Suppose this highest power n is 2, then this is a quadratic polynomial. If highest power n is 3, then it is cubic polynomial and so on. See, the rule about polynomial is, this is the rule. Where exponents means power, where exponents of variable are only whole number. This is the rule about polynomial. That in a polynomial, the exponent, the power of the variable. What is the variable here? This polynomial is in terms of x. The variable here is x, right? So the power of x in each of the term has to be a whole number. This is the rule about polynomial. The power of x in each of the term, as you can see, should be a whole number. What are whole number? I hope all of you knows that. That whole number is whole numbers. Starts from 0, then 1, then 2, then 3, then 4, and so on. These numbers are known as whole number. So power should be one of these. Power can be 0, power can be 1, or 2, or 3, or 4. The power of x. So the power of x has to be a whole number, then it is known as a polynomial. Otherwise, we can't call it as a polynomial. Okay. Now, let's take an example. Let's take few example. For example, px is equal to 2x plus 3. Is this a polynomial? Yes, this is a polynomial. This is known as linear polynomial. This is known as linear polynomial. Example 1. Example 2, let's say that px is equal to 2x plus root 3. Is this also a polynomial? Yes, this is also a polynomial. Both of these are linear polynomial. Linear polynomial. Okay. Both of these are known as linear polynomial because highest power of x is 1 over here. If the power of x is 1, then we call it a linear polynomial. Okay, both of these are polynomial. Whether there is 3 or there is root 3 or there is root 2 over here, that also works. But if I ask you this thing, example 3, px is equal to root x plus 4. Is this a polynomial? No, this is not a polynomial. Because here the power of x is not a whole number. Here the power of x is 1 by 2. Power of variable has to be a whole number. Here x is the variable. What is the power of it? 1 by 2. That is not a whole number. So this is not a polynomial. This is not a polynomial. We will just call it an algebraic expression. This is an algebraic expression. This is not a polynomial. Okay. Here we have root 3. Okay. Still it is a polynomial. Right. Because see, 3 raised to the power 1 by 2. Root 3 is a constant. Here the power of variable is not, fraction. Here the power of variable is a fraction. Okay. So I hope you understand the difference between these two. Moving ahead. Now, if I ask you which of the following is a polynomial, okay, like 2 upon x plus 2. See, whenever there is x in the denominator or whenever there is a variable in the denominator, it means that its power is minus 1. Like suppose 1 by x is written, see in the option D, 1 by x is written. It means x raised to the power minus 1. This is x plus x raised to the power minus 1. This is not a polynomial. This is not a polynomial because x is in the denominator. If the variable is in the denominator, basically its power is minus 1. So option A is not a polynomial. Option D is not a polynomial. Option B is not a polynomial because the power of the variable is 1 by 2. But option C is a polynomial because here power of x is 1. Okay, basically it is 1 by 2 times x, right? 1 by 2 times x. This is a polynomial because here the power of variable is a whole number. So this is a polynomial. Suppose if I make few more options, option E, okay, let's call it root 2 times x. Is this a polynomial? Yes, this is a polynomial. This is a polynomial. Because here power of x is 1. Power of x is a whole number. This is a polynomial. This is a linear polynomial. Okay. EF, let's say x plus 1 by x plus x cube. Is this a polynomial? This is not a polynomial because we have x in the denominator. It means that the power of variable is minus 1 over here. Okay, power of variable x is minus 1 in this term. So power of variable cannot be, anything else than a whole number. So this is not a polynomial. So I hope you understood the basic definition of a polynomial. What do we call a polynomial? Let me give you a few examples of polynomial like linear, quadratic, cubic. Okay. Px is equal to 4. Is this a polynomial? Px is equal to 4. Is this a polynomial? Yes, this is a polynomial. This is known as 0 degree polynomial, right? 0 degree polynomial. Because the power of variable, see, there is no x present over here. So what's the power of our variable? The power of our variable is 0. So we call it 0 degree polynomial, or we call it constant polynomial, or constant polynomial. Okay. Now example 2. Px is equal to, I have already given you so many examples of linear polynomial. Let me give you some quadratic polynomial. Okay, like 2x square plus 4x minus root 3. Yes, this is a polynomial because see here we have x raised to the power 2, here we have x raised to the power 1. See, these are coefficients. Okay, there is a term called as coefficient. This 2, this is a coefficient. This 4, this is a coefficient. This root 3, this is a coefficient. So if I ask you what's the coefficient of x square, you will say coefficient of x square is 2. What's the coefficient of x? That is 4. What is coefficient of x raised to the power 0? That is minus root 3. Or we also call it constant term. Also call it constant term. Okay. Yeah, because this term is constant. This term is not dependent upon x. See, there are 3 terms I can see in this. One of the term is 2x square. This is not constant because if x changes, this term changes. Another term is 4x. That is not constant. This minus root 3 is a constant term. It is not dependent upon x, right? So it is also called as constant term. And 2 and 4 will be called as coefficients. Coefficients can be anything. Coefficient can be a rational number or an irrational number. Okay, but we'll be talking about in terms of real number only. So coefficients can be anything. This is a quadratic polynomial. Okay, this is a polynomial and this is quadratic polynomial. And this chapter revolves around quadratic polynomial. We'll be talking about quadratic equations, quadratic polynomial a lot. Px is equal to 4x cube plus root 3 times x minus 1. Okay. Yes, this is a polynomial because power of x is 3, power of x is 1 over here. So as we can see that in each of the term, power of variable is a whole number. So this must be a polynomial, and this polynomial is known as cubic polynomial. Okay. This polynomial will be called as cubic polynomial. Coefficient of x cube is 4. If I ask you what's the coefficient of x square in this equation, coefficient of x square will be 0 because the term of x square does not exist, right? Coefficient of x square will be 0. What's the coefficient of x? That is root 3. What's the constant term? Constant term is minus 1. So I want you to get familiar with these terms, the coefficients, the constant term and all. Now let's get to our first theorem of quadratic equation. Okay, remainder theorem. We'll later on get into quadratic equation, but before that I want you to learn these theorems, which is very, very important. Many amazing questions are being asked on this in JEE exams as well. So what is remainder theorem? If a polynomial, remainder theorem says that if a polynomial px is divided by x minus a, okay, if I divide a polynomial by this linear factor, this is a linear factor x minus a, then the remainder obtained is p of a. This is the statement. Okay. Now let's understand the proof of it. Let's understand the reason behind it. Why does this happen? Okay. Now, one thing all of you must have heard, that dividend is equal to divisor multiplied by quotient. I'll explain this, don't worry, plus remainder. Right? This works. This works every single time, whether you divide two numbers or whether you divide it to expression. This works every single time. This is a identity. Like let's say suppose if I divide 13 by 4. Okay. Now what is 13? Okay. 13 is known as the dividend. Okay. The one thing that is getting divided, this is known as the dividend. 4 is what? 4 is the divisor. 4 is divisor. There must be some remainder, right? You tell me what will be the remainder when I divide 13 by 4. So everybody knows that 4 3s are 12. If you divide 13 by 4, the remainder will be 1. Let's see whether this works or not. Okay. Whether this thing works or not. This thing. Dividend is equal to divisor multiplied by quotient plus remainder. Okay. Now what is quotient? See, if I divide 13 by 4, 4 3s are 12. Okay. And 1. Okay. This thing is known as quotient. Okay. This is, I have already told you, this is dividend. This thing is divisor. Okay. And this is remainder. Okay. So is this working? Yes. Dividend, which is 13. Dividend, which is 13, is equal to divisor multiplied by quotient. 13 is equal to divisor multiplied by quotient, which is 4 into 3 plus the remainder. Remainder is 1. Yes, this thing is working. 13 is equal to 4 3s are 12. 12 plus 1, that is 13. So dividend is equal to divisor multiplied by quotient plus remainder. Okay, that's the thing. Right, everybody? Okay. Now if I divide two polynomials, okay, this thing will work if I divide two polynomials as well, right? Suppose if I divide two polynomials, division of polynomial. Let me explain that. Division of polynomial. You must have done this in your class 9th or in your class 10th. You must have divided polynomials. Suppose if I ask you that divide up polynomial, let's say I give you a cubic polynomial. Let's say x cube plus 4x square plus 3x plus 1. Okay. x cube plus 4x square plus 3x plus 1, and I'm asking you to divide by x minus 2. Okay, what will happen if I divide this cubic polynomial by this linear polynomial? How do I divide this? What will be? Okay, we can already see the dividend. We have the divisor present, we have the dividend present. Now what will be the quotient? What will be the remainder? Let's divide that. So how do we divide this? So I hope you guys remember that. First of all, I have to cancel out this term x cube. So I will multiply this x minus 2 with what? With x square. So that x square multiplied by x minus 2. What will happen? X square multiplied by x, that will be x cube. Minus 2 multiplied by x square, that will be minus 2x square. So this is what we get. Okay, if you multiply by x square, we get x cube minus 2x square, and then you subtract this and this term gets cancelled out. What is 4x square minus of minus 2x square? From 4x square you are subtracting minus 2x square. So here I am going to get 6x square. Here I am going to get 6x square, right? 4x square minus of minus 2x square, I will get 6x square. Then this plus 3x, I am dropping this plus 3x. Now I want to cancel this term 6x square. So what should I multiply it with? I have to multiply it with 6x. Okay, I will multiply by 6x. So that 6x multiplied by x minus 2, I will get 6x square. And 6x multiplied by minus 2, I will get minus 12x. Agreed? Now again this term of 6x square gets cancelled out. 3x minus of minus 2x will produce 15x. Correct? 15x. Then I am dropping plus 1. Okay, last term is remaining plus 1. Now again division can be continued. I can cancel out this 15x if I multiply this thing by 15. Right? So I'm writing here plus 15. So 15 multiplied by x minus 2, 15 multiplied by x minus 2 will produce 15x minus 30. Right everyone? 15 multiplied by x minus 2 will produce this, and now 15x gets cancelled out. 1 minus of minus 30 will produce 31. Now the division stops over here. Now I can't cancel out 31, right? Division stops over here. Okay, this 31 is what? This is remainder. This is remainder. So of course we can find remainder by properly dividing. This is remainder. This is what? Quotient. Okay. So of course by proper division we can find remainder. But this remainder theorem gives us a very smart way of getting to this remainder. Remainder theorem is not concerned about quotient. What is quotient? Nobody is asking you about quotient. They will be asking you about remainder. That what will be this remainder? And how do I get to this number 31 directly without doing all this division? How do I get to this number? So first of all, I wanted you to, recall this division, which you must have learned in your 9th or 10th class. So first of all, recall this, and then I'll present to you a very amazing method by remainder theorem. Okay, so now how does remainder theorem tackle this question directly and gets to the remainder? This is my question. Okay, now see, the question was I am dividing x cube plus 4x square plus 3x plus 1. Okay. X cube plus 4x square plus 3x plus 1. I am dividing it by x minus 2, right? This was the question. This was the question, right? And what was the question basically? I need to find the remainder. Now I'm directly writing that thing, that dividend is equal to divisor multiplied by quotient plus remainder. Right everybody? This is the thing. Dividend is equal to divisor multiplied by quotient plus remainder. I'm interested in this term. What is remainder? Okay. Now what is dividend over here? Dividend is x cube plus 4x square plus 3x plus 1. What is divisor? Divisor is x minus 2. What is quotient? We don't know. Okay. To find quotient, we have to properly divide. And we are not going to do that because we just need to find remainder. We just need to find remainder. Let's call remainder r. Okay. Now, how do I get the value of r? Look at this equation carefully. Look at this equation carefully and think about it. How do I get the value for this? How do I get the value for this? So very simple idea. If I make this term 0, if I make this term 0, I will get r. I will get the value for r. Now, how do I make this term 0? What value of x should I put over here so that this term becomes 0? So you know that to make it 0, you simply need to put x is equal to 2. Put x is equal to 2. In this equation, if I simply put x is equal to 2, this entire term becomes 0. What do I have in the right hand side? Only r. Only r. Correct. So in the right hand side, we have r. This term has become 0. If I put x is equal to 2, this term has become 0. In the right hand side, we have r. And when I put x is equal to 2, what do I get in the left hand side? I am getting 2 cube plus 4 times 2 square plus 3 times 2 plus 1. 2 cube plus 4 times 2 square plus 3 times 2 plus 1. Okay. Am I getting the value of r from here? Yes, I can see that. This is 8. This is 4. 4 into 4, 16. This is 6 plus 1 is equal to r. So we have 8 plus 6, 14. 14 plus 1, 15. 15 plus 16, 31. So I'm getting the value for r as 31. This is the soul of remainder theorem. Okay. This is the soul of remainder theorem. So remainder theorem also says the same thing. The process that I have done, the result that I'm going to show, the statement that I'm going to show about remainder theorem. Let's have a look at that statement again. Let's have a look at the statement again. If a polynomial px is divided by x minus a, then the remainder obtained is p of a. This is what remainder theorem says that. See, what is the dividend? Dividend is px. Because polynomial px, this is dividend. What is the divisor? Divisor is x minus a. And what are we looking for? Remainder. They are saying that remainder will be p of a. Let's understand. So again we know that dividend is equal to divisor multiplied by quotient plus remainder, right? This is the thing. Now what's the dividend? Dividend is p of x, this polynomial p of x. What is divisor? Divisor is this x minus a. We will have some quotient which I'm not worried about. I'm only interested in this remainder. Okay? Or I'm simply writing quotient as q only. Okay? Q plus r. So dividend is equal to divisor multiplied by quotient plus remainder. I'm only looking for r. Now what value of x should I put to get this r? So simply put x is equal to a to get r. Okay. To get this value of r, simply in this equation, put the value for x as a. If you put the value for x as a, in the left hand side, I'm getting p of a. I'm getting p of a. If I put x as a, this term becomes 0. This term becomes 0. And in the right hand side, I'm getting r. So what is r? R is p of a. R is p of a. Okay. As simple as that. Basically, I'm putting that value of x where this divisor expression becomes 0. I'm putting that value of x where this divisor expression becomes 0. Suppose if the divisor is x minus 2, I will put the value for x as 2. Suppose the divisor is 2x minus 1. Now this time, what value of x should I be putting? I should be putting the value for x as 1 by 2. Because at x is equal to 1 by 2, this thing is becoming 0. So this time, the remainder will be p of 1 by 2. Okay, now let's practice some examples so that you get a better and better understanding. Polynomial px, a cubic polynomial divided by this. What's the remainder? So either I can directly write remainder will be p of 1. You know? Basically that value of x where this divisor expression becomes 0, that will be remainder. Polynomial will be p of 1. Basically if I put the value for x as 1, I'll be getting 1 plus 2 minus 1 minus 3, that will be a remainder. 1 plus 2 minus 1 minus 3, that will be a remainder, which is what? Which is minus 1. Remainder will be minus 1. Okay? Directly using the remainder theorem. Now let's again understand the reasoning behind it. Why we are putting p of 1, why the remainder is p of 1. Again I am explaining the reasoning behind it. The reasoning is that see, there is a polynomial px. Okay, the divisor is x minus 1. There will be some quotient, there will be some remainder. Dividend is equal to divisor multiplied by quotient plus remainder. To get this value of remainder, I need to put that value of x where this divisor term becomes 0. So if I put x is equal to 1, in the left hand side, I'll be getting p of 1, and this term becomes 0, and that will be the remainder. That will be our answer. That I have directly written. Okay. Let's have a look at this question. Now if I divide this polynomial by this divisor 2x minus 1, what will be the remainder? So this time I'm putting the value of x as what? P of, in this polynomial, I'll be putting the value of x as 1 by 2. Because at x is equal to 1 by 2, this divisor expression is becoming 0. That will be the remainder. P of 1 by 2 will be the remainder. So if I put the value for x as 1 by 2, I'm getting 1 by 2 cube, okay, plus 2 times 1 by 2 square minus 1 by 2 minus 3. This will be our remainder, okay, which is 1 by 8. 2 times 1 by 4, which is 1 by 2, minus 1 by 2, minus 3. Okay, now this 1 by 2 terms gets cancelled out. We have 1 by 8 minus 3. We have 1 by 8 minus 3. Okay, 8 3s are 24. 1 minus 24 will be minus 23, minus 23 by 8. That's our answer. That's the remainder. I hope this remainder theorem is clear to all of you. Now, the second theorem, which is known as factor theorem. The second theorem is a factor theorem, which is super important. Super important. See, what is a factor? What is a factor? Like you must have heard that before getting to a factor theorem, I want to emphasize upon what is a factor. Okay. Now, let's understand through some examples so that it is easy to recall for you guys. If I ask you, if I tell you that factors of 12 are 4 and 3. Do you agree? Factors of 12 are 4 and 3. Basically, I can write 12 as 4 into 3. Of course, the factors of 12 are 2 and 6 also. I can write 12 as 2 into 6. Factors of 12 are 4 and 3 or 2 and 6 or 1 and 12, right? These are the factors. I can write 12 as 4 into 3, or I can write 12 as 2 into 6, or I can write 12 as 1 into 12. True? True. Okay. Now, if I say 4 is a factor of 12, it means that 12 is exactly divisible by 4. That's the thing. Right? Correct? If I say that 4 is the factor of 12, if I say 4 is factor of 12, it means that 12 is exactly divisible by 4. Basically, in other terms, if I tell you that if I divide 12 by 4, the remainder is 0, right? If the remainder is 0, if I divide 12 by 4 and remainder is 0, right? Remainder is 0. So if the remainder is 0, then it is a factor. 3 is a factor of 12. 1 is a factor of 12 because if I divide, right? 12 is a factor of 12 because remainder is coming out to be 0. Okay, so basically just an example, let's say that there is 50. Okay, so I can say that 25 is a factor of 50, right? 25 is a factor of 50. Why? Because when I divide 50 by 25, the remainder is coming out to be 0. Okay. Why? Because remainder is 0. Okay. This is, we are talking about in terms of numbers. In terms of expression, it is still the same thing. It is still the same thing. I will say that this expression is a factor of this expression. Okay. If I divide this expression by this expression and the remainder is coming out to be 0, then it is a factor of this expression. The remainder is coming out to be 0. What's the essence? The remainder is coming out to be 0, then it will be a factor. So if the remainder is 0, okay, now let's get back to this expressions. Now if P of A is 0, read this statement. If P of A is equal to 0 for a polynomial Px, then x minus A is a factor of the polynomial Px. Yes, what is P of A? You have just seen this P of A, right? P of A is the remainder, right? Recall that in remainder theorem, we have just studied that P of A is remainder. P of A is what? Remainder when Px is divided by x minus A. Okay, we have just seen that P of A is remainder when Px is divided by x minus A, and this thing says that if P of A is 0, if remainder is 0, okay, 4 is a factor of 12. 4 is a factor of 12. Why? Because remainder is 0. When I divide 12 by 4, the remainder is 0. That's why I can say that 4 is a factor of 12. Okay. In the similar way, if this P of A is 0, basically if remainder becomes 0, then x minus A is a factor of Px. X minus A is a factor of Px. Okay. This is known as factor theorem. We use factor theorem to find the factors of expression. To factorize an expression, we use factor theorem a lot. Okay, to factorize the expression, we use factor theorem a lot. For an example, like let me take a very basic quadratic expression. Let's say x square minus 4x plus 3. Okay, I'm looking for its factor. I want to factorize this thing. I know that each one of you can factorize this thing by middle term splitting method. Now we want to see factor theorem in this. That how does factor theorem reflect in factorization? So everybody can factorize, everybody can say that x minus 3 multiplied by x minus 1, these are going to be the two factors. Everybody can factorize, right? Just middle term splitting method, you know that method, right? So you can factorize like this. Now let's have a look at the factor theorem. See, when I put x as 3, this expression becomes 0. This thing becomes 0 at x is equal to 3. Okay. See, at x is equal to 3, this expression becomes 0. Hence, x minus 3 is a factor. Yes, very simple. At x is equal to 3, this expression is becoming 0. We can observe that. Put the value for x as 3. This will become 9 minus 12 plus 3. 9 minus 12 plus 3 is 0. So at x is equal to 3, this expression becomes 0. Hence, I can say that x minus 3 is a factor. Same goes for x is equal to 1. That at x is equal to 1 and dash 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 dash. Same thing. At x is equal to 1, this expression becomes 0. Hence, x minus 1 is a factor. Hence, x minus 1 is a factor. Okay. Got it? So that's how I can factorize this. If I know that at what values of x the expression is becoming 0, I can find the factors of that expression. Because this is a quadratic expression, there are 2 factors. If this is a cubic expression, there will be 3 factors. Okay, degree 4 expression, there will be 4 factors. Okay, so depending upon at what value of x this expression is becoming 0, that will be the factors of that expression. Clear? Super clear? Now, let's have a look at this question. If px is equal to x square plus bx plus c and p of 1 is 0 and p of 2 is 0, then find the value for p of 3. An expression is given. We don't know the value for b, we don't know the value for c. We have the coefficient of x square as 1. I know 2 values of x where it is becoming 0. I know 2 values of x where it is becoming 0. What are those 2 values? 1 and 2. I know that at x is equal to 1. Basically, do you understand the meaning of this information? The meaning of this information is that at x is equal to 1, this thing is becoming 0. So I can definitely say that x minus 1 will be a factor. At x is equal to 2, this expression becomes 0. So I can definitely say x minus 2 will be a factor. So definitely this expression will be product of these 2 factors. I know the factors by this information. So I directly know this expression that our px expression is going to be this thing only. Our expression px is going to be x minus 1 into x minus 2. This can be the only possible thing. Because this is quadratic, their multiplication is also quadratic. This becomes 0 at x is equal to 1. This also becomes 0 at x is equal to 1. This becomes 0 at x is equal to 2. This also becomes 0 at x is equal to 2. And coefficient of x square also matches. Coefficient of x square is 1. If you multiply this, here again the coefficient of x square is 1. So this is our expression px. This is our expression px. If I multiply these two, I will get x square minus 3x plus 2. Their multiplication will produce this thing. This is our expression px. Yes, everybody. See, coefficient of x square is 1, coefficient of x square is 1. What is the value for b? If you compare, here the coefficient of x is b, here the coefficient of x is minus 3. The value of b is minus 3. The value of c is plus 2. The value of c is plus 2. Okay, this is our expression px. Now they are looking for the value of p of 3. Just simply put the value for x as 3 in this expression. If you put x as 3, you are going to get 3 square minus 3 multiplied by 3 plus 2, which is basically 3 square is 9 minus 9 plus 2, which will be plus 2. This is the value for p of 3. This is method 1, which is using factor theorem. Okay. Method 1, which is using factor theorem. Directly using factor theorem, they have told me the values of x where this expression becomes 0. So I know its factor, that at x is equal to 1, this expression becomes 0. So x minus 1 will be a factor. At x is equal to 2, this expression becomes 0. So x minus 2 will be a factor. And this is the expression. We got the expression. Yes, there is another way. There is direct way. There is another way. Basically, method 1 is preferable method. Method 1 works in difficult equation, in lengthy equations, this method will work. But this method is not going to work in a lengthy equation, in difficult equation. This method is not going to work. But still, yeah, there is another way, and that way goes like this. That way goes like this. That okay, P of 1 is 0. This is our expression Px according to the equation. This is our expression x square plus bx plus c. This is the expression Px. At x is equal to 1, P of 1 will be 1 plus b plus c. Do you get it? At x is equal to 1. This becomes 1. B into 1 will be b plus c is plus c. P of 1. This is P of 1. And they said that P of 1 is what? Equal to 0. Okay. So I get an equation in terms of B and C. Right. This is one of the equation. Let's call it equation 1. Now they have said P of 2 is also 0. So I'm writing P of 2. What will be P of 2? In place of x, if I put 2, 2 square, which is 4, plus b times 2, that will be 2b plus c. This will be P of 2. 2 square, b into 2 plus c. P of 2 is also what? 0. Let's call it equation 2. In front of us, we have two equations and two unknowns. What are those unknowns? B and C are the unknowns. Two equations, two unknowns. Can we solve it? Yes, of course we can. Right? Of course we can. Just simply subtract these two equations. C will get cancelled out. If I do this, equation 2 minus equation 1, what do I get? Equation 2 minus equation 1, 4 minus 1 will be 3, 2b minus b will be plus b, c minus c will be 0. So this is what I get. Equation 2 minus equation 1. This is what I get. 3 plus b is equal to 0. So what will be the value for b? The value for b is coming out to be minus 3. If I put back the value of b as minus 3 in equation 1, I'll get the value for c, right? So that will be 1 minus 3 plus c is equal to 0. 1, you know, putting the value for b as minus 3. So 1 minus 3 plus c is equal to 0. So I'm getting the value for c as 2. If I put the value for b as minus 3, c as 2, am I getting the polynomial px? Am I getting the polynomial px? Yes. That x square, putting the value for b as minus 3, I'm getting minus 3x, putting the value for c as plus 2, plus 2. Yes, everybody? This is our expression. X square minus 3x plus 2, I got to this expression in 2 steps over here. Here I have to follow few steps, right? I had to solve equations. And lengthier the equation, the more equation there will be if you go by this method. So definitely we are not going to prefer this method. We are going to prefer this method of factor theorem. Really amazing questions are made on this basic concept. Really amazing questions are made on this. Okay? Everyone got this thing? Got this thing? So px, we got x square minus 3x plus 2. Here I directly got px as x square minus 3x plus 2. So that's the thing. Okay. Now, moving ahead. Let me do a slight change in the question. Okay. Question is factorize 4x square minus x plus 3. Okay. Factorize this expression. Factorize 4x square minus x plus 3 using middle term splitting method. Okay. Using middle term splitting method. Factorize this expression. Okay, everybody can do this. That I am going to break this minus x into two parts, minus 4x plus 3x. Right, everyone? Minus 4x plus 3x. So I am going to write this as 4x square minus 4x plus 3x plus 3. I'm going to write like this. Okay. Now taking 4x common, so 4x times x minus 1, okay, minus 4 plus 3. Okay, there has to be minus 3, sorry. There has to be minus, little bit change in the question. Okay. 4x square minus x minus 3. I'm going to split this between minus 4x and plus 3x. Okay. So we have 4x square minus 4x plus 3x minus 3. I'm taking 4x common from these two terms and I'm taking 3 common from these two terms. So 3 times x minus 1. So what are the factors? X minus 1 is one of the factors. Another factor is 4x plus 3. X minus 1 times 4x plus 3. These are the factors. Okay, simple, yes. Now what I want you to learn from this basic example. See guys, factorization means if I say that its factors are x minus 1 and 4x plus 3, these are the factors. Okay, I have factorized this. I have seen that these are the two factors of this expression. X minus 1 times 4x plus 3. Correct? Correct, correct, correct. These are the factors of this question. This thing. Right. Now, what are the roots? What are roots? What are roots of this expression? What are the roots of this quadratic equation? So you can say, sir, x is equal to 1 is a root. Right? What are roots? 1 and minus 3 by 4. Correct? These are the roots of this expression. If I ask you what are the roots of this quadratic, you will say that roots of this quadratic are x is equal to 1. Because at x is equal to 1, this is becoming 0. Roots are basically those values of x where the quadratic equation becomes 0. So you can say, sir, yes, x is equal to 1 is a root. And 4x plus 3 becomes 0 at x is equal to minus 3 by 4. If you are not directly getting to the roots, you can also apply Dharacharya formula to get these two roots. But everybody understand these are the roots of this equation. Now let's do some reverse engineering. Okay. Now reverse engineering. I am presenting the same question in a different format. Now my question is that polynomial presenting the same question but with different reverse engineering we are doing now. Okay, polynomial 4x square plus bx plus c has roots, or we can say polynomial px is equal to 4x square plus bx plus c, and p of 1 is 0 and p of minus 3 by 4 is 0. Then find px. Find px. You get the question? Polynomial px is equal to 4x square plus bx plus c is given. I am saying that p of 1 is 0, p of minus 3 by 4 is 0. Basically it becomes 0 at one end, minus 3 by 4. Now I am looking for this polynomial. Reverse engineering. Okay. Now, how do I use factor theorem here? See guys, directly using in one line I am going to find this polynomial 4x square plus bx plus c. Okay, this is the polynomial. I need to find this. I have its two factor. I know that at 1 this becomes 0, so definitely x minus 1 is going to be factor. I know that at x is equal to 1 this thing becomes 0, so x minus 1 is going to be factor. I know that at minus 3 by 4 it is becoming 0, so x minus 3 by 4, which is x plus 3 by 4, will be factor. One of the factor is x minus 1. Another factor is going to be x plus 3 by 4. Because at minus 3 by 4 this becomes 0. So x minus of minus 3 by 4, which is x plus 3 by 4, this is going to be another factor. But still, left hand side and right hand side are not matching. Not matching. What's the problem? The problem is we have to match the coefficient of x square. There should be a number 4 in the multiplication. Then the left hand side and the right hand side matches exactly. There should be a number 4 in the multiplication. Coefficient of x square, you have to match the coefficient of x square. Okay, so look over here. See, I told that these are the two factors. These are the two factors. If I take 4 common from it, if I take 4 common from it, what do I get? I get 4 times x minus 1 multiplied by x plus 3 by 4. This is the expression 4x square minus x minus 3. Have we written the same thing? Yes, this thing are same to same. Okay, so 4 times x minus 1 multiplied by x plus 3 by 4. This is our expression. This is our expression. This is the value we are looking for. Okay, I hope it is clear to all of you. So that's the thing. If I know the roots, if I know where does this become 0, where does this polynomial become 0, I get the factors. But I also should be knowing the leading coefficient. This thing is also known as the leading coefficient. These two informations are okay to find factors. These are the informations to get the factors. Yes, these are the two factors. But I should be also knowing the leading coefficient to know about polynomial. Here I can observe that leading coefficient of x square is 4. Now these two sides are the same side. So from here we get this concept. What's the concept? The concept, the core concept of a quadratic equation. The core concept of a quadratic equation. The concept is, if ax square plus bx plus c, a polynomial px is equal to ax square plus bx plus c, has roots alpha and beta. If this px has roots alpha and beta, if this is given, then I can write this px. I can write this px as a times x minus alpha, x minus beta. I can write this polynomial px as a times x minus alpha, x minus beta. See, alpha, beta are the roots. They will determine the factors. I get the factors x minus alpha, x minus beta, because I know that alpha and beta are the roots. But we have to match the leading coefficient as well. So now these two expressions are the same expression. Now this expression and this expression are same. And from here we can derive the formula of sum of roots, product of roots. Yes, from here we can derive the formula of sum of roots and product of roots. See, if I equate these two, if I equate ax square plus bx plus c, because I told you these two are the same expression, is equal to a times x minus alpha into x minus beta. I am equating these two. See, what's the right hand side? Here I have a times, if I multiply these two, x multiplied by x will give us x square. Then we have minus alpha times x. Then we have minus beta times x, right? You can multiply two expression. Then minus alpha into minus beta will give us plus alpha beta. Correct? Now, we have a times x square. From these two terms, if I take minus x common, minus x times alpha plus beta plus alpha beta, right? These are the things we have. Multiply a inside. So if you multiply a inside, we have ax square minus x a times alpha plus beta a times alpha beta. Okay, this is the right hand side. What's the left hand side? The left hand side is simply ax square plus bx plus c. See, if you now compare these two sides, this is a very, very interesting thing, guys. Okay, if you now compare the two sides, okay, now compare it. We have ax square, we have ax square here also. Here we have coefficient of x is b. If I ask you what's the coefficient of x in this, b, and what's the coefficient of x in this one? The coefficient of x is minus a times alpha plus beta. So if I compare coefficient of x, on comparing coefficient of x, okay, coefficient of x in the left hand side is b, right? And in the right hand side we have the coefficient of x as minus a times alpha plus beta. Now what's the value for alpha plus beta from here? You must have heard that alpha plus beta, which is the sum of the roots, is minus b upon a. That's the value for alpha plus beta. The value for alpha plus beta, minus b upon a, and this is where it comes from. Okay, this is how I define it for cubic, a degree 4 equation. This is the relation between roots and coefficients. See, a and b are the coefficients. In this expression, a is the coefficient of x square, b is the coefficient of x. Alpha and beta are what? Roots. The relation between roots and coefficient comes from this logic, this concept. Okay, if I compare the constant term, see, we have plus c as the constant term. Here the constant term is a times alpha plus beta. So again, on comparing constant term, the constant term in the left hand side plus c, in the right hand side we have a times alpha plus beta. So we can say that c is equal to a times alpha beta, right? C is equal to a times alpha beta. So the value for alpha beta is c by a. The value of product of roots alpha beta is c upon a. So this is where all these things comes from. Okay, this is where all these things comes from. That sum of the root alpha plus beta minus b by a. The product of the roots alpha beta is equal to c by a. And then we have another formula, difference of the root alpha minus beta, that is under root d by modulus of a. This is derived from these two only. Okay, this is derived from these two only. But I hope you understood the derivation of these two results. I hope you understood their derivation. Okay, like basically this thing also works for a cubic expression. This thing is going to work for cubic, a degree 4, a degree 5 expression. Suppose for a cubic expression, if I write for a cubic expression, ax cube plus bx square plus cx plus d equal to 0 if its roots are alpha, beta, gamma. Alpha, beta, gamma. This time we'll have 3 roots, alpha, beta and gamma. So now I can say this cubic equation is equal to this ax cube plus bx square plus cx plus d is going to be equal to, if alpha, beta, gamma are the roots, then x minus alpha, x minus beta and x minus gamma are going to be its factor, and a is the leading coefficient. Now again these two sides are the same side. If I multiply these 3 factors, okay, you can try this multiplication on your own. I am directly multiplying it. I am not going to make many steps. Okay, because I'm good at multiplication, I will directly multiply it. You try it by yourself, you will also become good at multiplication. So if I multiplied these three, we get x cube minus x square times alpha beta plus beta gamma, x square times alpha plus beta plus gamma. I'll be getting this. See, coefficient of x square will be what? See, we have x into minus alpha. So x square into minus alpha. So minus alpha x square minus beta x square minus gamma x square. So this will be the coefficient of x square. The coefficient of x is going to be alpha beta plus beta gamma plus gamma alpha, and the constant term minus alpha minus beta minus gamma, minus of alpha beta gamma. This will be the constant term. So I have skipped a few steps. What you can try, if you want to do, or you just understand the crux of it. But if you want to do, you can multiply these two, then multiply this by this, and then you will observe that you will be getting this same expression. Okay. Now, see, here we have ax cube minus x square into a into alpha plus beta plus gamma plus x a times alpha beta plus beta gamma plus gamma alpha minus a times alpha beta gamma. This is what we have, right? Now comparing, again comparing. See, this ax cube matches. Now what's the coefficient of x square? Plus b. So I can write plus b is equal to, here the coefficient of x square is plus b, here the coefficient of x square is minus a times alpha plus beta plus gamma, minus a times alpha plus beta plus gamma. So from here I can say that alpha plus beta plus gamma is minus b by a. For a cubic expression, again this is known as sum of roots. Sum of roots is what? Minus b by a. If I compare this thing, that coefficient of x is this, here the coefficient of x is c. If I compare these two, what do I get? I get c is equal to a times alpha beta plus beta gamma plus gamma alpha. So I can say that's sum of the roots taken two at a time. Alpha beta plus beta gamma plus gamma alpha. This is known as sum of the roots taken two at a time. This is sum of the roots taken one at a time. So sum of the roots taken two at a time is what? C by a. Third thing, comparing these two terms. Constant term, here the constant term is plus t. So minus a times alpha beta gamma is equal to plus d. So the value for alpha beta gamma is equal to minus d upon a. This is known as product of roots. Sum of roots minus b by a, sum of roots taken two at a time plus c by a, product of the roots minus d by a. Now this is going to work for cubic, then degree 4, degree 5, degree 6, whatever degree the expression is, the same pattern is going to follow, and this is the logic behind, relation between roots and coefficient. Okay. For an example, if I give you a cubic equation, 4x cube plus 3x square plus 2x plus 1 equal to 0. If I ask you that its roots are alpha, beta, gamma, then what is alpha plus beta plus gamma? That will be minus b by a. This is b. A is the coefficient of x cube, b is the coefficient of x square, c is the coefficient of x, and d is the constant term. So you can see a, b, c, d, right? So minus b upon a, it will be minus 3 upon 4. Then the next thing, alpha beta plus beta gamma plus gamma alpha, minus b by a, then plus c by a, then minus d by a, then plus, minus plus minus plus. This is going to go on like this. This is the pattern we are seeing. Minus b by a, then plus c by a, plus c by a, plus 2 by 4, plus 2 by 4. That will be alpha beta plus beta gamma plus gamma alpha. Then if I talk about alpha beta gamma, minus plus, then again minus. Okay, minus plus, then again minus d by a, minus 1 by 4. Okay, everybody, minus 1 by 4. Okay, if this is a degree 4 expression, like, or let's take few more example of cubic only. X cube minus x plus 1 equal to 0. X cube minus x plus 2 is equal to 0. Suppose this is the cubic equation I am asking. Again, the same three equations. What are some of the roots? These three equations. Again, these are the three values I want to write. So what is alpha plus beta plus gamma? Okay, that will be minus b by a. Now what is b over here? B is 0. Can you see this? 0 upon 1, that will be 0. Why? Because b is 0. The reason being that b is 0. B is the coefficient of x square. Minus b upon a. B is 0. B is the coefficient of x square. Okay. Then we have alpha beta plus beta gamma plus gamma alpha. That will be plus c upon a. C is the coefficient of x. What's the coefficient of x? As we can see that c is minus 1. Okay. So we'll have c upon a. C is minus 1, a is plus 1. C is minus 1, c is the coefficient of x. C is minus 1, a is plus 1. So alpha beta plus beta gamma plus gamma alpha will be equal to minus 1. Sum of roots taken 2 at a time, minus 1. Now the last thing, alpha beta gamma, product of root. Minus b plus c, then minus d by a, right? Minus d by a. And what's the value for d in it? The value for d is plus 2. Okay. So we have minus of 2 upon 1, which is minus 2 only. So this is known as theory of equation. This works in degree 4 or degree 5 or degree 6. Like suppose if I write degree 4 expression, x raised to the power 4 plus 3x cube or plus 5x cube minus 2x minus 3x square, let's say, okay, plus 10x plus 1 is equal to 0. This is, so now this time we'll have 4 roots, alpha, beta, gamma, delta. We have 4 roots. The same thing again, if I ask you what's the value for alpha plus beta plus gamma plus delta, sum of roots, then you will say minus b by a. If I ask you sum of roots taken 2 at a time, which is basically alpha beta plus beta gamma plus gamma alpha plus alpha. Okay, directly summation alpha beta, I can write like this. Sum of roots taken 2 at a time, which will be plus c by a. Third thing, summation of the roots taken 3 at a time. 3 at a time means alpha beta gamma plus beta gamma delta. Okay, plus alpha gamma delta, sum of roots taken 3 at a time. So I have taken alpha beta gamma, I haven't taken delta. Here I have haven't taken alpha. Now I'll be not taking gamma. Okay, sum of roots taken 3 at a time. Minus b by a plus c by a, then the pattern continues, minus d by a, and in the end alpha beta gamma delta, that will be minus c by a. See, compare this thing with a degree 4 expression like this: a x raised to the power 4 plus bx cube plus cx square plus dx plus a equal to 0. Compare this with this, then you will be easily able to see the value of a. A is 1, coefficient of x raised to the power 4. B, coefficient of x cube 5. C, coefficient of x square minus 3. D, coefficient of x, which is 10, and E is the constant term. The pattern follows: minus b by a plus c by a minus d by a plus e by a plus. Okay, So just simply put the values. Minus b by a, b is 5, so minus 5 by 1, which is minus 5. Okay, plus c by a, c is minus 3, c is minus 3, so minus 3 upon 1, a is 1. Then minus d by a, d is plus 10, so minus 10 by 1. Okay, minus d by a, putting the value for d as 10. And then plus e by a, what is the value for e? Is plus 1, plus 1 upon 1. We have our answers. That's it. So that's it for our session. We are going to continue in the next session. Okay, and we'll be doing many more examples. We'll be talking more about theory of equations in the coming session. So I hope everything is clear to you about this session. I hope you enjoyed this one. See you in the next one. Till then, this is your maths teacher Kundan Makar signing off. Tada, bye bye. Have a great day, everyone.